Hello and welcome to Straight Talk, Supply Chain Insights, the podcast for your supply chain leader who is on the go and wants to be in the know. And now, your host, Lora.
Welcome to Straight Talk with Supply Chain Insights. My name is Lora. I'm the founder of Supply Chain Insights, and I am currently interviewing supply chain technology leaders to get insights on the future of supply chain technologies with a specific interest in supply chain planning. Today, I'm very fortunate to interview Joannes Vermorel. He is the CEO of Lokad, and I think that Lokad is doing some fascinating work on use of open source technology and new forms of mathematics. Joannes, welcome to the show. Tell the group a little bit about yourself.
So my background is a mathematician. I started a PhD in computational biology, never finished it, and instead created Lokad, my own company, which is basically at the cross-section of machine learning and big data for supply chain optimization.
Now, you've been doing some fascinating work with open source and schema and read. Where do you see the future of supply chain planning?
So what is really interesting that I see is a more holistic perspective on supply chain. So what do I mean? I mean that planning is typically about, having a vision that is clearer to execute better the future. But where the situation, the way I see it, gets very hairy is when your very decisions modify this very future. So you see the classical perspective, you have kind of forecasting on one side, and then you have planning, and then you have purchasing. You have a lot of things that are kind of, I would say, staged and made relatively independent. And what is interesting is that fundamentally there's tons of things that are highly interconnected, especially in supply chain, such as, for example, if you purchase more, you can maybe get a better price from your supplier, so you can actually build a better offer, so sales more, reach more markets, and so I would say recoup more margin in the end just because you've actually engineered more demand through producing more, et cetera, et cetera. Traditionally, I would say there was like little hope to be able to embrace those kind of retroactive loops in your supply chain planning system. I mean, retroactive loops of actually having your hands in control of, let's say, the pricing, the price point where you're going to sell the goods, the finished goods. But now it becomes possible, and that means that suddenly planning becomes a lot more entangled with all sorts of things that were considered as probably separate, such as pricing and marketing operations, and even, I would say, to a large extent, like customer analysis, meaning analysis at the level of the customer behavior, which is something that brands can do if they have some e-commerce where they see how the clients interact and what are the actual purchase behavior directly on their e-commerce front end.
So with the advancements in open source and math, what should people do? Because, what you're working on is not quite baked yet, and what should people do?
So my take is that for many companies, they are, I would say, still not paying enough attention to their data. And I'm not talking about, collecting data from Twitter feeds or social network or like the sort of super advanced stuff. I'm talking of really the basic of exactly knowing what you're selling, what you're purchasing, and having good master data. I mean, people are surprised. I mean, many companies, even many people in companies that are supposed to be like world leaders and that are world leaders on their markets. My observation is that frequently they have still nowadays they have a lot of weaknesses where the data is nowhere near as agile as it should be. When basically you just want to answer a question as simple as what do you have in stock right now, and that includes everything that is in transit. Already, I would say probably half of our super large clients cannot right now even answer those sort of questions. I would say with like almost perfect accuracies. They should be, because it's not about the future. There is no uncertainty. It's just about pure matter of knowing what you have, including what is currently moving. So probably there is like attention to the data, which is the starting point to do any kind of optimization. And the second thing is, once you pay attention to your data, is to realize that optimization is always a matter of trade-off. So it's pointless to say, oh, we want 100% service level, or we want 0 defect, or we want 0x, 0y. It doesn't work like that in an imperfect world. What you want is a very, very good trade-off. So basically, if you're willing to sacrifice 1% fill rate, you just need a very valid, profitable reason to do so. And it exists. And there is plenty of situations where, so in terms of optimization, if you want to optimize, you need to think that it's a matter of trade-off and not absolutes. Because as soon as you say, I want 0 stock out ever, for example, it's infinite stock, so it just doesn't work mathematically. So, and here it's typically frequently a big change for many companies to start thinking that there is no absolute. There are just stuff that happens to be incredibly expensive when not done properly, but incredibly expensive doesn't mean infinite costs. Sometimes, even in aerospace, the cheapest option is still to ground an aircraft, which is extremely expensive. But if your alternative is to buy a pair of new engines, where each engine costs $15 million each, then grounding the aircraft for one more day might still be cheaper.
You know, the concepts that you talk about, getting clean data and really dancing with areas of gray and getting clear on absolutes, is something. Hang on, my dog has a ball. I've got to get this ball so that we'll edit this. The areas that you talk about of getting clean on master data and really thinking about trade-offs sounds simple, but it's not. And, you know, can you talk a little bit about your clients? Don't they have ERP systems and advanced planning systems? Why is this difficult?
It's difficult because it violently conflicts with status quo, and it makes tons of people unhappy. Just to give you an example, you take a retail network, you know, a general merchandise retail network. As soon as people optimize the stock in the point of sales, they are going to realize very, very quickly that the stock in the point of sale serves 2 distinct purposes. One is to ensure availability to the customers, and the other one is to make the store appealing, so that there is like a high willingness to buy stuff because the store looks good. So basically, you have the merchandising stock and the servicing stock, but fundamentally there is only one stock. There is whatever is in the store. But as soon as you start introducing this kind of quantitative optimization, you realize that a certain portion of the budget should go to supply chain because it's the servicing stock. So it's really about fulfilling the demand. And the other one is about generating the demand, which this budget should go to marketing because it's an investment, just like you could buy ads on TV. And as soon as when we move forward with clients and we start to uncover these sort of things and put them forward, you can imagine that the marketing director that end up with like tens of millions of dollars of budget that are pushed onto his or her department, they're not happy. You know, it doesn't look good. It's the status quo that has been around for a long time, and suddenly you can have like literally a lot of inviting. And and same thing, for example, for what I was describing about the pricing versus the planning, and you realize that a very, very smart planning need to take into account what is going to be done pricing-wise, which means that the planners need to kind of get control to some extent to the pricing strategy. And suddenly, whoever was in charge of the pricing strategy is not happy at all about this interference from those planners who, in the past, used to be, contained in the backside of the supply chain and mostly harmless. And suddenly, everyone expects a lot more from them, and maybe a bit less from the pure pricing. Or you see, so that's where this quantitative perspective is so hard. It's not that the metrics themselves are difficult; it's that frequently, by just writing it down, it shatters the status quo.
Well, in this whole area of absolutes, I've been working with a lot of clients who want control towers, but I say, let's think about control theory. And control theory says that we should manage within targets and bands, and that we are conscious about what we're going to control. And something like in-stock availability, a new supply chain leader says he wants 100% in stock, without knowing what those costs are, right? They tend to think in absolutes. So in your work with clients, how do you get them over these humps to think about trade-offs and absolutes and data cleanliness?
So data cleanliness, and I would say more importantly, because usually the problem is it's not that the data is unclean, it's more like the IT landscape is a mess. So unfortunately for solving, I would say, mess of the IT landscape, I don't see any quick solution. I know that the very good companies that are typically, I would say, aggressive e-commerce, highly digitalized, they were digital natives, they pay a lot of attention to have like a lot of applicative urbanism. So they really think it through of all their apps, how they interact, how they are going to have all the solutions play well with each other, which requires a lot of engineering and careful thinking, not necessarily much time, but people who are really good at designing the applicative landscape. Unfortunately, it's harder to reproduce this sort of, I would say, a focus on non-digital native companies, but still kind of required. That's one part. The other part is for those trade-offs. But that's a bit an act of faith. But I mean, with Amazon being bigger and more successful every day, I would say it's less and less an act of faith of being like a core focus on your applicative landscape. It's just about replicating literally the Amazon recipe. But for those trade-offs, I think the culture should be that things should be measured in dollars or euros. You need to put a price tag on stuff. And here there is one, I would say, danger in doing that, is to put a naive price tag. So that's what is very important, is to put a price tag that is smart, I would say business smart. Just to give you an example, for most, for example, for most brands, like let's say luxury brands, if they do a promotion tomorrow, the promotion itself would be like a massive hit. But the net outcome would be that the brand would be damaged. If you're Louis Vuitton, like a luxury brand, you do not do promotion ever. You can't buy your Louis Vuitton bag that is normally costing $2,000 at a discount. There is no discount ever. So that's the sort of things where what is dangerous with, I would say, those criteria, that you need to be smart and aligned when you're measuring dollars with the core value of the business. But that being said, having a business that is complicated to model is not an excuse to not even try to model anything. Because obviously, if you don't model anything, that means that you're kind of stuck to optimize anything, because you end up with tons of options that are kind of unqualified, supply chain wide. I could do more of this, more of that, extra, and it's all shade of gray and then politics rules. If you have no numbers, in the end, you end up with decision being made purely on the political influence of this person or this person, the organization, who might be right, or, by the way, or wrong. It's just that it's just subjective, and it's very, very hard to improve upon the status quo.
Well, let's shift gears. How real is non-relational open source technology? I work with a lot of clients that have always been working on schema on write and relational databases and don't know what terms like Apache Spark mean or Kafka or, you know, some of the work that's happening in the open source community. How real is it? And, you know, the data science teams that tend to be more science projects and ad hoc, are they going to become mainstream? And if so, what's the time?
So you see, Hadoop came from Facebook, TensorFlow comes from Google, CNTK comes from Microsoft, etc., etc. So the key insight is all those, like, you know, data crunching open source toolkits, they all come from those tech giants, and they are used in production by those tech giants. Why are those tech giants open sourcing this very good stuff? The answer is because they're fighting like hell for talents. If you're Google, the strategy of the Google is to do whatever they can, whatever it takes to hire the best and brightest, including, you know, disclosing the best parts of their technology, if it's what it takes, to capture the interest of literally the most brilliant mind of the century. That's their strategy. And they have been kind of quite successful at it. So bottom line, it's very real. I mean, those open source, because there are actually things used at scale in production by companies that are tremendously successful with it, which are basically Google, Amazon, Apple, Microsoft, literally. So that's where those projects come from. So it's very real. It's very, I would say, production grade, because actually those systems were basically stuff that are in production that have been frequently been released as open source just for hiring for basically human resources as a very, very smart long-term vision on human resources and how to capture the interest and the mindset of literally the ecosystem, the tech ecosystem at large. Now, those for companies who are, I would say, not those digital giants, beware, because once you're aware of that, you know that it's production grade, you know that it's actually working, but you can see also that there is an ever-growing need to always release more stuff and more variant and more things. You know, if you're Google and what you want is, recall your primary target is hire the best and brightest, you end up in a frenzy of pushing more stuff like all the time, you know, as open source. As a result, there is a danger for I would say non-tech companies or companies that just to be kind of overwhelmed by this like frenzy of stuff that is pushed to the market. And here the classical advice that I have for my clients is you need to have like I would say tech-wise a strategy that is fire and motion. So you keep firing, you keep moving. You don't stop on just jumping from one framework or one set of tools to another, because it's like ever changing. And for example, a couple of years ago, people were all rage about Hadoop, and now Hadoop is gone, and they're all rage about Spark. And tomorrow, people will be all rage with the descendant of Spark. The reality is that Hadoop is quite good. Spark is better, but only marginally better, and the descendant of Spark will also be better than Spark, but marginally better. So bottom line is that it's better to choose a set of tech, stick to it, make the most of it, get to production, as opposed to jump like literally every 6 months to whatever is the shiniest thing of the day, because as a company that is typically large, having a big supply chain and having a sheer bit of inertia, it takes, you know, a year or maybe more to get things rolling in production. So you need to stabilize a bit. But other than that, it is very real. It is very production grade. And I mean, it's no chance if literally all the massive, you know, breakthrough in let's say computer vision, automated translation, playing Go and beating the worldwide champion of Go, etc. None of it has been done with relational databases or relational systems. None of it.
But today's IT landscapes are all about relational databases, and you say pick an architecture and stick with it. Most manufacturers have picked Oracle or SAP or their friendly relational database. And, there's tension here. How do they migrate, and what should their strategy be as we think about supply chain planning and, 5-10 years? Because I think it'll be open source.
Yes, I mean, first, my take is relational databases are excellent when it comes to asset management. When it comes to manage your asset, your goods, transform goods, manage your clients, just keep manage in the sense of keep track of them and keep track of the transformations or whatever operation is applied to any of those objects that lives in your system. So relational databases are not going anywhere, and whatever has been, making progress on machine learning side, it doesn't change that. And even, the Google of this world are still using extensively relational databases. What I'm saying is that so that's the first point of my answer. Second point is that relational databases have now open source solutions such as, let's say, PostgreSQL or MySQL, which are excellent. For a long time, Oracle with King. Oracle was the only company to have like a really production-grade relational database, maybe with IBM DB2. For a long time, there were very, very few contenders in this space, and even fewer who had anything that could scale. Nowadays, PostgreSQL literally scale up to the volume that you need to deal with literally the Procter & Gamble of this world. So it's like massively scalable. Even if Oracle still has a small edge, the reality is how many companies really need to have are like bigger than Walmart. So that would be the point, is that even for those rational database landscape, which I believe will stay, open source is coming and coming strong. Now, the thing is, what you will not get with relational system is that you don't get numerical optimization ever. Those systems are not designed for that. They never were, and basically they never will be. I mean, for deep architectural reasons, this is not what they are made for. So it means that for planning purposes or anything that is like data intensive, where it's basically data crunching, statistics, numerical optimization, it has to be different class of systems. And here that's why, and that's where all those non-relational systems, like again Google TensorFlow, let's say Lokad, selling my own stuff, my own company, but all those specialists about data crunching comes into play as a counterpart for the relational system that do not manage anything, but that optimize decisions on top of those systems, so that it's very complementary.
Well, we're going to have to go now. I could talk to you all day. I consider you one of the top leaders in the industry working on, the next generation of supply chain planning. So we'll come back and do a second part. Thanks very much for your time today. Until next time.